Good morning everyone. So already last class some part is completed in the structure of polynucleotide chain. So last class what we discussed, so what are the nucleotide components, that means nitrogen bases, pentose sugar, phosphates, we discussed in the polynucleotide chain what contain the components. Next, what is meant by nucleoside and what is meant by nucleotide and how to formation of phosphodiester bond we discussed in the polynucleotide chain. After that, we have to continue this polynucleotide chain in the DNA structure. That means the number of nucleotides. Then this is the one nucleotide, this is another nucleotide, this is the another nucleotide. All together to the formation of this is the chain. This is the polynucleotide chain. In that structure of DNA, this is containing this one number of nucleotides are present in DNA also. So what is meant by here? The 5' end of nucleotide. What is meant by here? 5' end of nucleotide chain. 5', this is the prime. This is what you call this line. This is a 5'. So how it is that I will show you the DNA structure also. Okay, 5' end of nucleotide chain. The ribose sugar has 5' end. Where it is that? It is a 5' end. This one. This is the 5' end. The chain. This is the OH group is present. This is the 3' end. 5' to actually polynucleotide chain always change from 5' to 3' direction and 3' to 5' direction. Opposite strand also. Okay. So in that 3' end, what is the group? OH group. It is the hydroxyl group is present. Hydroxyl group is present. So now in the polynucleotide chain, what is meant by here? The 5' end of polynucleotide chain. The ribose sugar has, also the ribose sugar has at the 5' end region, this is the 5' end, phosphate group is present. Okay, in the nucleotide chain region, in the nucleotide, the polynucleotide chain, this is the single nucleotide. So single nucleotide phosphate to sugar and nitrogen base. This is the altogether this is called, it is the nucleotide. A phosphate group has 5' end of this ribose sugar. That's what do you call it? It is the 5' end of nucleotide chain. Definition is important. 5' end of nucleotide chain means phosphate group has 5' end region. Okay, so the phosphate group at where 5' end of ribose sugar, that's we call it is a 5' end of nucleotide chain. Next, 3' end of polynucleotide chain. 3' end of polynucleotide chain. See here, in the 3' end, which one is present there? Hydroxyl group is present. Okay, the ribose sugar has this one. The ribose sugar has 3' end OH group is present. That is hydroxyl group is present. A ribose sugar has 3' OH group. That's we call it is a 3' end of polynucleotide chain. In the polynucleotide chain, two definitions you can say. First one, 5' end of nucleotide chain, and another one, it is the 3' end of nucleotide chain. 5' end of nucleotide chain means here a phosphate group at where is present? The phosphate group, phosphate moiety. Moiety means group. The phosphate group is present at the 5' end of ribose sugar. That's we call it is a 5' end of nucleotide chain. 3' end means the ribose sugar has 3' OH group is present. Okay, 3' region OH group is present. So that's why this is called 3' end of. 3' or 3' end of nucleotide. Next, in the polynucleotide chain, the main backbone. In the polynucleotide chain, the main backbone of components, what are they? So the phosphate and also sugar are the main backbone, and also in the polynucleotide chain, one more it is the nitrosyl bases are the backbone. Okay, so in the polynucleotide chain, the backbone of the component phosphate and ribose sugar, and also the backbone of the polynucleotide chain, this is nitrosyl bases also. Nitrosyl bases also. Okay, next. In DNA, actually the DNA is a acidic substances. The DNA made up of already what is that? Polynucleotide chains. Already starting I said. The DNA is made up of the long chain of polynucleotide chains. So the DNA, it is acidic in nature. The DNA is the acidic nature. The DNA is a acidic in nature. And also present in where it is the nucleus. Present in nucleus. The DNA is the acidic substances. Okay, the DNA is the acidic substances and also present in nucleus. Okay, it was first. This DNA is first identified by the scientist Frederick Michel. Frederick Michel, very important. See, the DNA is the acidic substances that are present in nucleus. That is identified by the scientist Frederick Michel. He named it as nuclein. He named it as what do you call it as? It is nuclein. Okay. Next, after that, James Watson and Francis Crick proposed the double helical model of DNA. Double helical model of DNA. So this double helical model of DNA, how they are find means. The X-ray diffraction method. X-ray diffraction method that is discovered by Rosalind Franklin. Who was the scientist here? Rosalind. Maris Wilkins and Rosalind Franklin. Okay, so after that, the DNA is acidic substances that are present in the nucleus. That is identified the first the scientist, it is the Frederick Michel. So the Frederick Michel, such as acidic substances like structure, he named it as it is the nuclein. What is this one? Nuclein. Okay. Next, after that, the DNA double helical model is discovered. So the James Watson and Francis Crick, that means simply we call Watson and Crick. Simply we call it is Watson and Crick. The Watson and Crick, they are discovered the double helical model. Helix means turns. Double helical model of DNA. This double helical model of DNA discovered based on so X-ray diffraction method discovered by Maris Wilkins and Rosalind Franklin. So what is the X-ray diffraction method? What is meant by here? The X-ray diffraction method. X-ray diffraction method means in the nucleus inside what are the genetic material is present. This genetic material present in that some rays is, that is a light beam is passed on into that inside the nucleus. Passed into a nucleus. A light beam is passed into nucleus inside. So that based upon, that is discovered by, that is X-ray diffraction method. So that the rays, it can be elaborated the structure of this DNA material. Okay, so that based upon the James Watson and Crick, they are preparing the double helical model of DNA. Okay, that's it. Next, after that, next part, proposition of base pairing between the two strands. Actually, double helical model. Double helical model means sit like this present in the DNA. Double helical model of DNA. The Watson and Crick proposed, that means discovered. So the double helical model of DNA. This is the one helix. This is the another helix. Turns. Okay, so this is the one helix, this is the another helix, double helical model. Okay, after that, the proposition of base pairing. Proposition of base pairing between two strands. Okay, how it is the proposition? This strand is another strand. Strand, not stand. S-T-R-A-N-D. So this is the strand. The proposition of these two strands. Okay. Polynucleated chain based on, who is the scientist, means Erwin Chargaff. Erwin Chargaff. So once again see the proposition of base pairing between the two strands. So what are the components are present? One strand and also another strand. So the proposition of base pairing between the two is every polynucleated. This is the one polynucleated chain. This is the another polynucleated chain. Okay, so this polynucleated chain. So the base pairing, what are the base pairing? That means already said, base pair, a pair of nucleotide, we call it is a base pair. I said starting. Already said, what is meant by base pairing? We will discuss later. I said. So the proposition of base pairing. Base pair means a pair of nucleotide, we call it is a base pair. In the polynucleotide chain, every nucleotide chain. So these two nucleotide chains, so the two strands of the base pairing, okay, the proposition of base pairing, this polynucleotide chain, that can be explained by the scientist Erwin Chargaff. That is what he called, Erwin Chargaff. So this base pairing is the unique property to all living organisms. Okay, the unique property to the all major is the polynucleated chain. The base pairing is consists the unique property to the polynucleated chain. So that's why it's said to be a complementary. See, this is the word, it is different. How it is that meaning is applicable to this DNA strands. Base pairing confers the unique property to this polynucleotide chain. What is meant by here the base pairing? A pair of nucleotide. A pair of nucleotide. Already last class I said. So passport has the one formation 89. Suppose 89. So here between C. Base pairing is the unique property. Base pairing is the unique property to the polynucleotide. This is the one chain. This is the other chain. Okay. This is the one chain. That means this is the one chain. This is the another chain. So in the one chain, it is the, what are the components? Already told. The DNA, it is made up of polynucleotide chain. That means here nitrogen bases and here pentose sugar and phosphate is present. So adenine is always bonded with the thymine. So this is a unique property. That's we call it is complementary to each other. Complementarity. Complementary means adenine is always bonded with thymine. So this is the complementary to each other. Complementarity means adenine is always bonded with the thymine. That's what we call it is complementarity. Guanine is always bonded with cytosine. So that's why this is the complementary strand. It is unique, but except in RNA. So except in the thymine place, what is present? It is the uracil is present. So the base pairing is confers the unique property. This is the unique. Always whatever it is, the living organisms are present. This always so such a kind of it is the base pairing is present. All living organisms. But where it is the RNA is the thymine place. It is thymine place. What is present? Uracil is present. So this thymine always this thymine is always bonded with adenine. That means uracil is always bonded with adenine. So cytosine is always bonded with guanine. So this is the complementary. This is we call complementary to each other. So this is unique. Such a pairing is unique. Okay. What I am saying the point once again see. So here in the DNA structure, the base pairing, in a polynucleotide chain, the polynucleotide chain. So the proposition of base pairing here, proposition of base pairing based on Irving-Chargaff rule. So the base pairing, it is confers the unique property. This base pairing is always bonded with thymine. This is unique. And guanine is always bonded with cytosine. That is unique. Okay. So such a formation we call it is complementary. Such a adenine is bonded with thymine, guanine is bonded with cytosine. This is the unique. It is a complementary to each other. That's pairing we call it is complementarity. That's it. Okay. Next. Suppose each strand. Suppose for example in the DNA strand. This is the DNA strand. Each strand it can be separated. Suppose here each strand it can be separated. Each strand here act as a template strand. Each strand here act as a template strand. Template means it is a mother strand like that. Mother or parent strand. What do you call? Template strand. Suppose here these two strands are present. In the two strands, each strand is separated. Each strand is separated. So each strand here acts as a template. Template means what do you call? Here mother strand or parent strand. Okay? Here what do you call? Mother strand or parent strand. So after that, this template, it can be, what will happen? It can be formation of daughter strand. It can be formation of daughter strand. So based on complementarity means adenine is bonded with thymine, guanine is bonded with cytosine. So suppose here A is present, here opposite strand T is formed. Here G is present, here opposite strand C is present. Like that, so the mother strand to formation of opposite strand, that means a daughter strand is formed. This process we call it is a replication. This process we call replication. Once again see, so the DNA, in the DNA each strand is segregated, it is separated. So here each strand here act as a template strand. Template means what do you call? Parent strand. So the parent strand, okay, to the formation of daughter strand. So the daughter strand means same strand, same what are the base pairs are present. Base pairs means what are the nucleotides are present. Same base pairs are, that means nitrogen bases are not present in the opposite strand. So what are the, suppose here adenine, one strand is adenine is present. So opposite strand thymine is formed. Like that. Guanine, this is the G is present, that means guanine is present, opposite strand C is present. So that is daughter strand, opposite strand is formed. Such a process, the formation of daughter strand from the template strand, such a process we call it is a, what do you call? Replication process. Replication process. That's it. Okay. So next. Next, what are the silent features of? What are the silent features of? What are the silent features? What are the silent features of DNA? See here, I draw here very clearly. See, actually the DNA is made up of two polynucleotide chains. See, the DNA is made up of two polynucleotides. So this is a one chain and this is the another chain. Okay, the DNA is made up of two polynucleotide chain. And the backbone of this DNA, it is main phosphate. Okay, here phosphate is present and sugar is present and nitrogen bases are present. That means these nitrogen bases are present inside the polynucleotide chain. Okay, the DNA is made up of two polynucleotides. This is the one chain, this is the another chain. And in the DNA, the main backbone of this components is the phosphate and the sugar is present and nitrogen bases are present. And nitrogen bases are present inside only. And next one, this DNA show a anti-parallel polarity. The DNA structure is anti-parallel polarity. The DNA show a anti-parallel polarity. That means you can see here the DNA, this strand started from 5' end. It can be ends with 3'. Okay, and then opposite strand this one. So in the opposite strand it can be starts from, it is the 3' end here. So it can be ends with, there is a 5' end. This is called what do you call it here? 3' to 5' end and 5' to, that is a 3' end. Okay, so this is the direction. The DNA structure will show a anti-parallel polarity. So one strand you can start from, it is the 5' end, it ends with the 3' end, and opposite end you can say it starts from 3' end, opposite it is ends with the 5' end. So that's how we call it is the 3' to 5' end, and another strand is the 5' to 3' end. Okay, next, after that, the basis of two strands. The basis of two strands, this one, basis means nitrogen basis. The basis of these two strands paired with hydrogen bonds. Paired with hydrogen bonds. That means adenine is bonded with thymine. Guanine is bonded with cytosine. It is paired with the hydrogen bonds. So that means here adenine is bonded with thymine by two hydrogen bonds, and guanine is bonded with cytosine, here 3 hydrogen bonds. Okay, very important. So adenine is bonded with thymine by 2 hydrogen bonds, and the guanine is bonded with the cytosine by 3 hydrogen bonds. Okay, that's it. Next, these two chains are coiled with a right-handed fashion. Right-handed fashion means, see this one. This is what is the fashion? Right hand fashion. See, these are lines. Right hand fashion. This is the right hand fashion. See, right side onwards can be going. Coiling. Okay, lines. The DNA structure you can see here. Here made the two chains are coiled. The two chains are here coiled. Right-handed in fashion. Right-handed in fashion. Next. the pitch of helix. Main. The pitch of helix. Helix means where? Helix means what do you call it? It is a turn. That means you can see here this one. Yes, shape. This is the one complete turn. What do you call here? See. This is the turn. Yes, shape I draw now. See here. This one. This is the one complete turn. So one complete turn. This one. You can see this one. Pitch. Pitch means length. P-I-T-C-H. The pitch of helix. That means the length of one helix. How much means here? 3.4. How much? It is 3.4 nanometers. Or this is another call, it is 34 angstroms. 3.4 nanometers or 34 angstroms. Next, in that, a complete chain, that means this one, a complete helix, this one, a complete helix, this is the helix, this is the one helix, a complete helix, you have to complete turn this one, a complete helix, a complete helix, it contains how many base pairs? 10 base pairs. A complete helix, it contains how many base pairs? 10 base pairs. Next, the distance between two consecutive base pairs, this one. The distance between two consecutive base pairs, that means here see thymine and cytosine, adenine and guanine. So this thymine and cytosine, between the distance how much is present means 0.34. How much? 0.34 nanometers. Or 3.4 angstroms. Okay, next. The distance between two strands here 20 angstroms. How much? It is the 20 angstroms. That means 0.20 nanometers. 0.20 nanometers. Okay, this is the main. So, in the DNA structure, we get the main features. The pitch of helix, they are they are right-handed in fashion. That means see, right hand. This is like this only going right now. So the another strand also like this. This is the right-handed fashion. Left hand means they will go like this. This is the right side. It can be going. See here. This also you can see. But here left hand means it will go like this. Another opposite strand also here like this also going on. Like this. So this is the right-handed fashion. So in that, so what will happen? The pitch of helix, how much is 3.4 nanometers or 34 angstroms. And also the complete turn, this one, the complete turn of this DNA. A single turn of this DNA. How much of base pairs are present? Here 10 base pairs. The distance between two consecutive base pairs, how much? 0.34 nanometers or 34 angstroms. So the distance between two strands, the 30 angstroms are 0.20 nanometers. That's it. Okay. So these are the features and the planar, another feature. The planar base pairs. Planar base pair starts over the others. See, the planar base pair is GC. This is the plane. This direction. The planar base pairs starts over the other. Starts over the other means another base pair very different. G upper and a C upper, another nitrogen bases are formed. Okay, the planar base pairs starts over the other. That means starts over the means suppose in a chloroplast structure, thylakoids are how it is present like this. Starts over this thylakoids, other thylakoid. Like that, the planar base pairs starts over the other nitrogen bases. So in that, the nitrogen bases. In the nitrogen base, but in the presence of hydrogen bonds are present. These hydrogen bonds, it gives stability to the DNA. It gives stability to the DNA. That's it. These are the features of silent features of DNA. These are the 5 marks question point of view, very important. So once again see, so the silent features of DNA. So the DNA, once again see, I will repeat. So the DNA is made up of two polynucleotide chains. This is the one chain, this is the one another chain. So in that the backbone of main components is the phosphate and sugar, and nitrogen bases are present inside. Okay, so the DNA it show a anti-parallel polarity. Anti-parallel polarity means this one strand it starts from is the 5' end, it ends with the 3' end. Opposite strand is the 3' end, it can starts. So the 3' end it can be ends with the 5' end. Okay, and then so next in the two polynucleotide chains, the nitrogen bases are paired with hydrogen bonds. So the adenine is always bonded with thymine by 2 hydrogen bonds, and guanine is bonded with cytosine with 3 hydrogen bonds. So this is a unique property and also complementarity to each other. Complementary means adenine is bonded with thymine. This is a complementarity to each other. Okay, so this is also a unique property. Next, the pitch of helix. This is the pitch, that means here. If complete one helix means here. See, this is the one helix. The pitch of helix, this is 3.4 nanometers or 34 angstroms. Okay, and then so next a complete term it containing the base pairs. How much is the 10 base pairs? That means a complete helix containing the base pairs 10 base pairs, and the distance between two consecutive base pairs 0.34 nanometers or 3.5 angstroms. The distance between two strands, how much is 20 angstrom or 0.20 nanometers. And then next, the plane of base pairs. The plane of base pairs starts over the others. Starts over the other base pairs are present, same plane. So here the hydrogen bonds it gives the stability to the DNA structure. That's it. This is the salient features of DNA. Next. Erwin Chargaff. Next, Erwin Chargaff already told the proposition of base pairing. Proposition of base pairing adenine and thymine. This proposition of base pairing of these two polynucleotide chains proposed by the scientist is Erwin Chargaff. The Erwin Chargaff what they find in the adenine is always bonded with thymine by 2 hydrogen bonds, and guanine is always bonded with cytosine by 3 hydrogen bonds. This is we call it is Erwin Chargaff rule. This is what you call it is Erwin Chargaff rule. So that's why you can see here A plus Z. Here T plus C. Okay, so here you can see A plus Z by T plus C is always 1. How much of it is of purines are present? Pyramids are equal proportionally present. So this always is a 1:1 ratio it can be present. Purines are pyramids in the DNA structure. In the DNA structure, RNA structure that is not equivalent. Okay, so the Erwin Chargaff rule here adenine is always bonded with cytosine and guanine is always bonded with adenine is always bonded with thymine and guanine is always bonded with cytosine. So this is the AG means here AG, that means purines A plus G and T plus C. So here A plus G by T plus C is equal to 1 will come. So these purines and this pyrimidines. The purines are always equal to pyrimidines in the DNA structure. Okay, that's it. Erwin Chargaff rule. In the DNA structure, once again see 2 mass point of bearing bond. Adenine is always bonded with thymine by 2 hydrogen bonds, and guanine is always bonded with cytosine by 3 hydrogen bonds. So these purines are always equal to pyrimidines. So purines means A plus Z is equal to this the T plus C. Okay, equal to this is equal to 3 plus C. A plus C by T plus C is equal to 1. So this always is 1:1 ratio can be formatted. Okay, that's it. Next. So this is a DNA based upon DNA structures based upon already I said what is meant by polynucleotide chain. Once again see, so polynucleotide chain, the polynucleotide chain it can be made up of number of long chain of nucleotides. A pair of nucleotide we call it the base pair. Already how many base pairs are present in DNA structure we discussed. So in the polynucleotide chain, so what is meant by nucleotide, what is meant by nucleoside, and how to form the phosphate ester bond in the polynucleotide chain. 5' to 5' end of polynucleotide chain, 3' end of polynucleotide chain we discussed. After that, so here what are the main basic points of DNA structure we also discussed. So what are the salient features we saw. Okay, that's it. So next class we are going to discuss in the center dogma process and the packaging of DNA helix